Welcome back, ladies and gentlemen. We're starting off with example 1 here on using exponents or exponents rules. Now, you've probably got introduced to this in pre-algebra. This is going to be a little bit more of review at the beginning and in-depth at the end, because we're actually going to try to look at what it means to maybe have variables in the exponents and things like that by the end. So it's really important that we're making sure to pay attention here, because we're going to start off with those small rules that don't seem to mean anything but get really big ideas. So let's start with example A. Example A says that our exponent is 0. We have a rule for this, just like we have a rule for pretty much every time 0 is involved. That rule is anything to the 0 power is 1. So 6.7 to the 0 power is equal to 1. Now, we'll go over things of proof when you get to Algebra 2, because it's going to take things you haven't even seen yet, like limits. Which, funny enough, we're going to be talking about what leads into limits and even kind of beginning the discussion of what limits are this year. But you really get into it and can prove that anything to the 0 power is 1. So for now, it's just a rule. Now here we have B. B says that, oh, double tap that accidentally. There we go. We got -2 to the -4. Well, we know that -2 to the 4th would be the same thing as -2 times -2 times -2 times -2. The problem is, how in the heck do you do a negative? Because here's what people think, or would have the idea, and they'd be wrong. They think that, oh, because of this rule right here, then this, if 1 is true, B is true. And I purposely used a number and a letter there, by the way, if you didn't notice. Then that must be the same thing as 2 times 2 times 2 times 2, because we get rid of the negatives cancel. Or it could be some other weird stuff, okay? But this is not correct. So there's a rule when it comes to negative integers. I'm switching the word I want to use with the word I'm currently on. So negative integers is the inverse. Now, I don't mean inverse as in like inverse operation, so instead of multiplying, we're dividing or anything like that. What I mean is, in order to get rid of negative exponent, we put 1 over whatever it is we had, and then keep the positive. So basically, as weird as it might sound or seem, the negative on that 4 is actually meaning 1 over everything else you see. Now here we can take -2 times -2, which would be 4, times -2, -8, times -2, which would be positive 16. And so what that means is our answer is 1 over positive 16. So -2 to the -4th power is 1/16. So the two rules we went over, 0 or anything, I'll put it this way, any number no, I don't want to do that. I actually want to say anything, because we can't include variables. In other words, I'm alluding that there could be an exception down the line. Any number, I did it again, anything to the 0 power is 1. Not that the exponent becomes 1, the answer is 1. Now, by the way, I'm not alluding to that there's an exception to this rule of anything to the 0. There's just exceptions for zeros, I guess is kind of where I'm going with that. Again, that's a future discussion. Now, over here, the rule is anything to a negative power is placed under 1. I'll phrase it that way. There's different ways we could do it. Like I said, it's inverse, things like that. But really, it's just, it's placed under 1, okay? Actually, I'm going to take time real quick. If you want to be done, you're done. You don't have to watch the video. This is a little bit more in depth of where this 1 comes from, and it comes from the idea of inverse or inverting. So if you want to understand why that 1 is there, awesome. Keep watching. If you don't, go ahead and move on. You've got the information you need to be able to answer the questions and just be able to do them. Awesome. No big deal. So I'll leave it to you. Give you a few seconds to leave. All right, now that it's just us, the reason this exists, where we can just put it under 1, is what the negative is actually doing is it's telling us to invert our fraction. That's what a negative exponent actually does. So we have to think about -2 to the -4th, and think about that. Where's the fraction? Like, I don't see a fraction. Do you see a fraction? It's like Blue's Clues. What is it, boys and girls? Did you see a fraction? I don't see it either, okay? Sorry, having a little fun. But what we need to remember is that every number can be written as a fraction. In other words, what's in here is -2. I'm trying to keep that same color coding. Over 1 to the -4th. And what that negative does, just by its nature, and again, the proof is actually later on in mathematics, okay? So it's not something we can prove based on what we know. It's based on things that we will learn, okay? Math is weird that way sometimes, and I wish it got taught a little differently, that everything was kind of intuitive. In other words, everything truly built on itself, but there are some things we've taken from the end result of algebra and brought them back to start working on now, so by the time we get to the end, it makes a little bit more sense, okay? Don't worry about that. So a negative exponent means to invert our fraction. Invert is a fancy word for flip. Okay, so that means our numerator becomes the denominator, and our denominator becomes the numerator. And this is extremely important because what that means is if we flip the denominator to the numerator, it becomes 1 over, and then our numerator to the denominator is -2. And it's still to the 4th power, but because we inverted it, that negative in the power is gone. So this is the same thing actually as -1/2 times -1/2 times -1/2 times -1/2. And I'm just going to write that here. I'm going to add a little bit of room for me. And since I'm trying to color coordinate, here we go. Is the same thing as, well, -2 times -2 is 4. -2 times 4 is -8. And we end up with the same answer of 1 over 16. So this is what's actually going on. The shortcut is just remembering it's just the same number or same answer under 1, which is why we gave the definition of under 1, because really that's the simplified way of writing or thinking of inverting a fraction. It's under 1. So that was a little bit more in depth as to what's going on with that negative exponent. If you stuck around this long, awesome. Hit that like and subscribe button. Do it if you want to. It doesn't matter to me. But hopefully that makes a little bit of sense, and I've been able to go over why it's actually just under 1, or you could just memorize that it's under 1. I don't need to worry about it beyond that. It's really up to you on the depth at which you want to understand the math that's occurring or going on in the background.